Hello friends, this is Professor Dr. G.S. Wajire from Department of Electronics, Sri Shivaji College of Arts, Commerce and Science, Akola. Friends, today's topic for discussion is physical idea and types of negative feedback. First, we will discuss about physical idea of negative feedback. We will discuss this topic on block diagram levels. A feedback or any closed loop amplifier can be represented by two blocks, one for an amplifier and other for a feedback circuit. So there are four following ways to connect these blocks. Actually, these connections are shown in subsequent figures. These four connections are classified according to whether the voltage or current is feedback to the input, and also either they are connected in series or in parallel with the input. So accordingly, there are four types. Out of these four types, first is voltage series feedback, second is voltage shunt feedback, third is current series feedback, and last one is current shunt feedback. Come to first type is voltage series feedback. In the voltage series feedback circuit, a fraction of output voltage is applied in series with the input voltage through the feedback circuit. This is also known as shunt driven series feedback, that is a parallel series circuit. Now try to concentrate on this circuit. In this particular voltage series feedback, the output voltage is taken in parallel with load RL by this feedback circuit, and it is connected in series with the input voltage Vi. That's why this feedback circuit is called as voltage series feedback. As the feedback circuit is connected in shunt with the output impedance is decreased, whereas due to the series connection with input, the input impedance is increased. Second type is voltage shunt feedback. In the voltage shunt feedback circuit, a fraction of output voltage is applied in parallel with the input voltage through the feedback network. This is also known as shunt driven shunt fed feedback, that is parallel prototype circuit. Again, try to concentrate on this circuit. In this circuit, the output is taken parallelly with the load resistance RL by this feedback circuit, and it is connected in parallel with input voltage Vi. As the feedback circuit is connected in shunt with the output and input as well, both the output impedance and the input impedance are decreased. Come to next type, it is current series feedback circuit. As the name indicate, in this type, current is applied in series with the input voltage through the feedback circuit. That's why this is also known as series driven series feedback. In short, it is also called as series feedback circuit. Again, in this circuit, from output, the current is taken in series with load resistance RL by this feedback circuit, and this quantity, it is connected in series with this input voltage Vi. That's why this is called as current series feedback. Here, the output quantity as a current is taken from output and it is connected in series with input. That's why its short name is current series feedback circuit. As the feedback circuit is connected in series with the output and the input as well, both the output impedance and the input impedance are increased. And come to last, it is current shunt feedback circuit. In this particular case of feedback circuit, the fraction of output current is applied in shunt with the input voltage through the feedback circuit. This is also known as a series driven shunt feedback, and in short it is also called as series parallel circuit. So as usual, if we see on output side, then it is seen that the output as a current is taken in series with load resistance RL by this feedback circuit, and then it is connected in parallel with this input voltage VI. So we can say current is taken from output and it is connected in parallel with input. And here, as the feedback circuit is connected in series with the output impedance is increased, whereas it is connected in parallel with input, that's why input impedance is decreased. So here in concluding lines, we can say out of these 4 types, voltage series feedback, it is used in most of the circuits, whereas the last one, current shunt feedback circuit, is used very rarely in the electronic circuits. So let's stop here. Thank you very much.